Hello everyone. So in my last video, I have started with one of the most important subject for the 6th semester mechanical students, that is heat and mass transfer. So in that we have started with heat exchangers. We have started with the heat exchanger unit. So last class we have seen the definition of heat exchanger, classification of heat exchanger, classification of heat exchanger. So in classification we have seen three types how the heat exchanger is classified. First is the based on the direction of fluid flow. Second one is based on the construction and design. Construction and let me write design and construction. Third one is we have classified based on the physical condition of the fluid. So direction of the fluid flow, first one. So in this we have seen three types. One is parallel flow, counter flow and cross flow. So in design and construction we have seen two types. One is concentric flow and shell and tube heat exchanger. So based on physical condition of flow we have seen condenser and evaporator. So all these things we have seen last class. So in this class I am going to teach you very important topic or concept which is very much important in this heat exchanger. That is nothing but fouling of heat exchanger. Fouling of heat exchanger. What is meant by fouling? See, basically what is meant by fouling means, suppose let me draw you a heat exchanger pipe, a pipe in a heat exchanger. So if I consider a pipe in a heat exchanger, see, there is a continuous flow of fluid. There is a continuous flow of fluid in this pipe. There is a continuous flow of fluid in this pipe. So the fluid flow is continuous. So due to the continuous flow, what happens? In the wall of the pipe, there is a scale or there is a rest formation. There is a rest formation in the wall of the pipe. So in the inner wall of the pipe, there is a rest formation. This is because of the flow of fluid. This is because of the flow of the fluid. So this continuous, because of the continuous flow of fluid, there is a rest formation in the pipe. So what happens when there is a rest formation means, due to over a period of time there will be a increase. There will be a increase in the thermal resistance. There will be an increase in the thermal resistance, which means there will be a drastic drop in the overall. There will be a drastic drop in the overall heat transfer. So what happens over a period of time, the efficiency of the heat exchanger drops. There will be an increase in the resistance, which means the heat transfer rate drastically decreases because of the rest formation happening in the flow of fluid. So we need to remember one thing. What is this? How is this happening? So we need to understand the flow of fluid. It may be water, but not all the times water. There may be some chemicals also. So the impurities which is which is in the fluid, causes the pipe to get rusted or corroded. So that factor, the rusting and corrosion of the surface of the wall of the heat exchanger, it is called as fouling. So this is the theoretical definition we can give for the fouling. So what happens? So if you just let the foul be happens, what happens? Mean we have seen there will be an increase in the thermal resistance, especially on the surface, and there is a drastical drop in the overall heat transfer rate. Fine. So let me write few sentences on this. The surface of heat exchanger, the surface of heat exchanger becomes foul with scaling or deposits of impurities of the fluid. So deposits of the impurity of the fluids, that can be water or any chemical which is used in the heat exchanger for heat transfer. So what happens when it is continuously flowing? What happens? There will be a chemical reaction. There will be a chemical reaction between there is a chemical reaction between the fluid and the wall of the heat exchanger. So in this case, what is the wall? So wall is nothing but the inner surface of the pipe. So this is called as, so because of that there is a rust formation. So because of the chemical reaction between the fluid and the wall surface, there is a rust formation. This deposits greatly increase. Greatly increase. What it increases greatly? It increases the surface resistance. Let me write RTH. It increases surface resistance and affecting the value of overall heat transfer coefficient. So what happens when we take this into account? There will be a additional thermal resistance. When we take the fouling into account, there will be a additional thermal resistance. That additional thermal resistance is called fouling resistance. That is called as fouling resistance. So we are going to derive fouling resistance and we are going to calculate what is the overall heat transfer coefficient. So what happens? So the overall heat transfer coefficient is determined by testing experimentally both in clean and dirt condition. What is mean by this? So we are going to compare the same heat exchanger when it is in new. When we purchase it new, it will be clean. There will be no fouling. After a span of time, it will become dirt, which means there will be a scale formation. So we are going to accordingly calculate by experimentally. We are going to calculate both in clean condition and as well as dirt condition. So RF, the resistance in fouling, can be determined as 1 divided by U foul, which means overall coefficient over a span of time when it is in foul condition minus when it is in clean condition. Then only we can able to analyze what is the difference of resistance, which means thermal resistance of the foul condition. This is important formula. Okay, fine. Let me try out now. Should come proper. Yes, fine. So when I want to calculate only the foul, I can write this equation as RF plus 1 by U clean. 1 by U clean. 1 by U clean. Sometime it comes, sometime it doesn't. Fine. Anyway, it should come. Fine. Okay. We'll try out one last time. Okay, fine. This is better. Okay. Now let us derive a simple derivation how to find the fouling factor. So let me consider a concentric tube. Let me consider a concentric tube. Yes, this is my concentric tube. Fine. So what I'm going to do is I'm going to take this tube, half part of this tube for my analyzation. Fine. So what happens in this tube means there is a flow of hot fluid. The Q it is generating, the heat is being generated due to flow. There is a foul happening here. There is a foul happening here inside this particular pipe. At the inner pipe there is a foul happening. Rust formation is happening. There is a sorry, rust formation happening. So the heat is flowing. The heat is flowing in between this inner and outer tube, and it is flowing to the atmosphere. At the outer end, what happens? The outer end, there is a foul happening. There is a foul happening at the outer. So there is a foul happening. Fine. So I am going to write this in terms of an electrical analogy. Electrical analogy. So I am going to take just this portion. Let me give this particular portion AA, because symmetrical portion is sufficient for us. So if I try to draw a electrical analogy, so I'll get a resistance, there is a heat transfer, there is a resistance, this resistance Ri, this resistance called as Ri. So because of the fluid there is a heat resistance taking place to the inner side. Then what happens? There is a foul taking place, Rfi divided by AFi. So foul is taking in the surface area. Next what happens? It passes through this portion. Let me call thickness of the tube. So what happens? There is a resistance R. So further there is a flow of heat. So let me consider R FO divided by AO. You can write in either way, not issue. You will get the same equation. And finally I will conclude with R naught. So in this way we are going to draw the electrical analogy. Now let me derive this equation. So if I want to write the summation of electrical resistance, thermal resistance. So I am going to write like this: Ri plus Rfi divided by AI plus R plus RFO by AO plus RO. Can interchange? No, that doesn't make any sense or any change. Sorry. So this is the total resistance. Let me write in one single stretch so that it comes as a proper rectangle. Very good. Fine. So this is our total thermal resistance. So let me write this. What is mean by resistance Ri at the fluid? It is nothing but 1 by Hi Ai. So we know the formula for resistance, plus, let me write the same, I am not going to change anything, plus R. R is nothing but there is a conduction happening here. So ln of r naught divided by ri divided by, let me write this equation, ln of r naught divided by ri divided by 2 pi kl. L is nothing but the thickness of this particular thickness is L. Fine. Difference of r naught and ri plus rfo divided by ao plus 1 by h naught by ai. So this is the formula for overall thermal resistance. So next what we are going to find is, we are going to find the overall heat transfer based on the inner side of the heat exchanger. So next what we are going to find is, we are going to find the overall heat transfer based on the inner side. So how to find that? So let us carefully look at it, how to find it. So UI, overall heat transfer inside, will give you 1 divided by AI into summation of RT. Summation of RT. So what we have done, we have just written the overall coefficient. So I have written RF, not a problem. Let me write as RF only. RF. Fine. So let me continue this derivation. Before that, I want this equation to derive this. We select this equation. Okay. I just missed. So I want this particular equation also. Okay, let me paste it. Fine. So let me call this equation number as 1, 2. Substituting equation 2 or equation 1 in equation 2. So let me substitute. What happens? So ui can be written as, this value I am going to substitute or multiply, and we'll see what happens. 1 divided by let me write ai, it will be common, 1 2 3 4 5, ai into 1 by hi ai plus ai rfi divided by afi plus ln of, let me write ai as I said, ln of r naught by ri divided by 2 pi kl plus ai rf naught divided by a naught plus ai 1 by h naught ai. So when we see this equation, we are going to remove the common term, ai get cancelled, and afi is nothing but again it is ai. We are going to cancel this, and is there any term? Yes, I think this should be not. This is not, because this is outer. just a minute. Yeah, okay, fine. Okay, so common term we have removed it. So if I continue my derivation further, let me write everything in term of diameter. I'll get an equation something like this. So 1 by 1 by 1 by hi plus rfi plus pi by 4 d square di square. So how the equation looks, it looks something like this. So di ln will be r naught by ri. This will be pi get cancelled, you will get 2 pi, sorry, pi get cancelled, so we'll get k. So we'll get k and l. So area, diameter. So inner we are going to take, if you take circumference, we don't get L. Okay. Circumference. Fine. Plus di rf divided by d naught plus di 1 by h naught d naught. So in terms of diameter, we'll get this equation. Okay, let me use this one. This is much more easier. Okay, fine. So this is the equation in terms of diameter. Fine. Now let us continue our derivation. So overall heat transfer coefficient in terms of outer radius or outer circle, whatever it is. So what will be how the derivation goes? So let me write the equation. U naught equals 1 by a naught by rf, summation rf. So similar way you need to derive. Similarly you're going to derive U naught equals, let me write the equation, 1 divided by a naught will be there, so 1 by hi ai plus a naught rfi by afi plus ln of r naught by ri divided by 2 pi kl a naught plus a naught by a naught r f naught plus a naught 1 by h naught a naught. So similar way, let me neglect the common terms. The final equation looks something like this in terms of d 1 divided by d naught 1 by hi di plus d naught rfi d naught di plus d naught ln of r naught by ri, so 2k plus a naught rf naught plus 1 by h naught d naught, d naught is removed. Okay, this will be give you the final equation. Yeah. So I'm very new to this tab. Okay, what is better? Okay, fine. So these are the equations. To find the overall heat transfer in outer as well as inner, and we can able to find the how much foul happened. So we'll stop here and we'll discuss in next class. Thank you.